Okay, so last time we introduced the notion of a limit. Okay, and the notation that we used to introduce a limit was something that looked like this. We said that the limit of f of x as x approaches c equals L. And what that means is that as x is getting closer and closer to c, f of x is getting closer and closer to L. And one of the easiest ways to kind of understand this on an initial looking at this is to consider a graph. And the idea is that this is kind of like a function. It's kind of like trying to figure out what the value of a function is at a point, but the caveat is that the function does not have to be defined at that point. And we saw that that was a useful notion for the purposes of an instantaneous rate of change problem. The idea is, let's say you had a point L, and the function wasn't necessarily defined at L, so I'm trying to graph the function f of x, and we're going to put a hole here. Granted, you don't have to put a hole there, but that's typically when things are most interesting. The idea was, well, if I know what's happening over here and I know what's happening over here, as x is getting closer and closer to c, we notice that the value of the function tends to get closer and closer to L. But the one caveat we didn't talk about last time is that this approach has to be from both sides. So what do I mean by that? I mean that if I were to draw a similar function and I had my point here, and this is my point L, and this is my point C, and my function was approaching C like this from the left, but I didn't have any approach from the right, as you can see in this graph, or maybe it's approaching a different value from the right. Either or, we don't have this condition of a limit. But the idea of one-side approach is still something that's useful mathematically, and we want to denote that, but we want to denote it a little bit separately. So the way in which we do that is we say that the limit as x approaches c, and we use this minus sign. Now this minus sign specifically just means from the left. So it's the same idea of a limit x gets closer and closer to c, but we only care about the one-sided approach as f of x gets closer and closer to L. So if I graph my function and I have my c here, and I have my L here, and I'm trying to graph f of x, in this particular example, we would be able to say that the limit as f of x, the limit of f of x as x approaches c from the left, and it's a superscripted negative sign to the right. Don't think of this as negative. This can certainly be a positive number. C in this case is positive. L can be positive. All that negative sign means is from the left. And there's, of course, the analogous definition of this one. We use a plus sign, and that just means from the right. And we get the right-hand limit if x gets closer and closer from the right. So it's the same picture, except here we have a c, we've got our point, and we've got something going on over here. And again, we can still have stuff going from the left. We could have other stuff, but this would be an example where this statement here is true. Okay, so let's do a practical example with real numbers. So here we've got the function f of x is equal to the absolute value of x over x, and these points here are going to be 1 and -1. Actually, the function is not defined at either of those points. Notice that if you plug a 0 into this function, you divide by 0, and f of 0 is undefined. So remember, a limit does not actually have to be the same value as the function. They can be totally different ideas. So if I were to ask, what is the limit as x approaches 0 from the left of f of x? Well, the answer is going to be -1. As you can see, it's from the left here. And the limit as x approaches 0 with a plus sign in this case is going to be positive 1. So one thing that is oftentimes confused is this notion of from the left and from the right. Notice that this is a from the right notation and not to the right. So it's not like you're like if this function was doing something here, I'm saying, well, notice these guys down here, they're going to the right. That's not what we're talking about. It's always the direction you're coming from, on the right hand side of the values of 0 and on the left hand side. So make sure you don't confuse those two things. If I were to ask, just as a hypothetical, what is the limit as x approaches 0 of this function, and I don't indicate a plus or minus sign, well, we would have to say that this does not exist. We oftentimes just abbreviate that with a DNE. And of course, the reasoning here is that we don't have a left-hand approach and a right-hand approach that are the same thing. So as a theorem, it actually turns out, and I suppose it makes sense, that the two-sided limit is going to be equal to L. So anytime we use limit notation, remember that it's implying two things. It's implying that the limit exists and is equal to L. So both of those are true. So the only way that this can happen, where the two-sided limit exists and is equal to L, is if the left-hand limit and the right-hand limit both exist and are both equal to L. So basically, if you have, let's say this is 4 and this is 2, I would be able to say that the limit of this function as x approaches 2 from the left is equal to 4, and I would also be able to say that the right-hand limit is also equal to 4, and because they both exist and they're both equal to 4, we can conclude that the limit as x approaches 2 without the plus or minus sign is equal to 4. So that is what one-sided limits are, and that's basically how they work. So I hope you enjoyed the video. Take care.